Okay, good afternoon, everyone. So in the previous class, we have started the turbine point. So where we discussed about the definition of turbine. Then later we discussed the classification of the turbine, right? So everybody should know it. This turbine is a power producing device or power absorbing device. It is power producing device because in the turbine, whatever the you can take example of a water turbine, or you can say, when I say water turbine, it means there we are using water as a source, as a resource, right? So when the water get flows toward the turbine side and it get strikes over the turbine bucket. So during this process, whatever the energy is there, that will be extracted, okay, and it will be converted into mechanical energy because the turbine is rotating with high speed as water is flowing over it, and whatever the energy we get, that is a mechanical energy, and that mechanical energy is converted into electrical energy by using generator, because the shaft of the generator and the shaft of the whatever the shaft, it is common for generator as well as turbine. So basic purpose of studying this turbine is to produce the mechanical power, and with the help of this mechanical power we can run the generator, we can rotate the generator and converts the electrical energy. That is the intention behind to study the turbine. Okay, now in this turbine, what are the classification we made? जे आपण क्लासिफिकेशन बघितलं होतं त्यामध्ये हाय हेड टर्बाइन. Okay, screen is not visible. So what are the classification of turbine? It is based on the three factors. First factor is according to the head and discharge of water available. Then second factor is according to the position of shaft, that is horizontal turbine and the vertical turbine. And third factor will be considered for the classification of turbine is according to the names of inventors. According to the names of inventors. So first inventor is Pelton Turbine, name of scientist Pelton. म्हणून त्याला काय म्हटलंय? Pelton Turbine, or you can call as a Pelton wheel. Second turbine is Francis Turbine. Name of scientist is Francis. Then third is Kaplan Turbine. Name of the scientist Kaplan. Okay. So as per the syllabus is concerned, only three turbines that we have to study or introduced in the syllabus: Pelton Turbine, Francis Turbine, and the Kaplan Turbine. I think up to this we have written classification and the definition.
Yes, sir.
Okay. So we'll move to the next slide. So please put the heading Pelton Turbine. Pelton Turbine. So this Pelton turbine is also called as impulse turbine. Okay, you can put in bracket impulse turbine. Impulse turbine. Okay, so we have to draw this diagram of the Pelton turbine. Okay, so please follow my instruction along with me. You have to draw the diagram. So draw the baseline first. Draw the baseline. Then you have to use pencil and scale for drawing the diagram. Hello. Am I audible?
Yes, sir.
Okay. So please draw the two vertical lines and this one spherical one, or it is a half circle, you can say.
छोटे छोटे स्टार्ट की जो पे आए तो पूरे छोड़ स्टार्ट इन कपड़ों से क्या होगा दूसरे गंदे सोच गंदे और गले पर बंदे टूटा बोलेगा साला
Hello, sir.
Okay. Any difficulty in drawing this diagram of the Pelton turbine? 50% completed or 100% completed? 70%. Okay. See, while drawing this diagram, you should take the care of two things. One is breaking jet is provided at the top. बघा वरती दिले बघ. हे जे ब्रेकिंग जेट आहे त्याच्यातून जे पाणी फ्लो होणार आहे, इट शुड गेट फॉल ओव्हर द बकेट. तिथून जर पाणी आलं तर ते बकेट मध्ये पडलं पाहिजे, नाहीतर ते बकेटचे जर पलीकडे पडलं त्याचा काहीच उपयोग नाही ब्रेकिंग जेटचा. त्यामुळं यू शुड टेक केअर द ब्रेकिंग जेट, position of the braking jet and this runner and what are the blades are present over it. Okay, so buckets and this braking jet flow of the water, it should get in line, एका लाईन मध्ये असले पाहिजे. Then secondly, deflector. So there's a deflector provided at the bottom, so that is used for deflecting the flow of water. Okay, then there is a nozzle, very decreasing cross section area at the end of the penstock. So what are the penstock is there? So at the end of the penstock, what are the cross section area is smaller one, it is acting like it is looking like a nozzle. Okay, whenever the cross section area get decreases, means definitely the velocity of the fluid get increases. Yes or no? velocity वाढते का नाही? जर एरिया जर कमी झाला, exit area जर कमी झाला तर what is velocity, increases or decreases? Increases. Yes. So accordingly you draw it properly. Then there is a spear. At the end there is a wheel. Then spear is provided over here. Chala?
Yes, sir.
Okay. But now see the construction of this Pelton turbine. See, whatever at actual, if you have visited the Koyna Dam, or maybe at this thing, our nearby dam is at Uzni Dam. Okay, so one power unit is there, right? So there also you can see the turbine over there. Okay, which is used for generating the electricity. So in this construction details, there's an important part is runner over which turbine blades are placed. Okay, these are the buckets we can call. Then there's a braking jet through which water is flowing over the bucket or backside of the bucket. Then there is a deflector. So this deflector is which is used for deflecting the water. Suppose if you want to stop this turbine, if you want to stop the runner, rotation of the runner, so you can divert the flow. जे काही flow तुमचा आहे jet of water, if you want to divert it, you can use the deflector. Then there is a spear is provided. The spear is used for controlling the flow of water. Suppose you want to increase the speed or increase the flow of water or decrease the flow of water as per the depend on the load condition. जे काही load condition असतात त्याप्रमाणे तुम्ही जे काही वॉटरचा फ्लो आहे तुम्ही कंट्रोल करू शकता by using spear. Then this is a penstock which is made up of concrete, because what are the pressure and the energy of the water which is entering through the penstock is very high. Okay, so to avoid the bursting or damage, so normally it is made up of a concrete. Okay, so if you make it of concrete material, then the life will be more. Okay, hence normally if you visit the power plant, or you can say where electricity generated, So definitely you can see the penstock is made up of concrete material only, right? So I hope that construction part you are clear. One second. So at the downside, a deflector is provided. So this deflector is provided to deflect the water. Suppose you want to stop the turbine. जर टर्बाइन तुम्हाला स्टॉप करायचं असेल तर पाण्याचा ते फ्लो असं खाली खेचला पाहिजे ना, म्हणजे ते पाणी जे बकेटवर पडणार आहे ते स्टॉप करण्यासाठी तुम्हाला ते डिफ्लेक्टर प्रोव्हाइड केलं. म्हणजे सपोज जे पाणी नोझल मधून येणार आहे ते जर त्याचं जेट तयार होत नसेल, काही पाणी डाऊन साइडला होत असेल तर यू कॅन यूज द डिफ्लेक्टर and deflector will deflect the water toward the bucket side. म्हणजे बकेट साइडला ते डिफ्लेक्ट करण्याचं काम करेल. म्हणजे जो फ्लो तुम्हाला कशा पण डिफ्लेक्ट करायचा आहे, समजा आता टर्बाइनला तुम्हाला स्टॉपच करायचं आहे, रेस्टला आणायचं आहे, तर तुम्हाला पाण्याचं जे काही पेनस्टॉक मधून जे पाणी येणार हाय स्पीड येणार ते जर कंटिन्युअस राहिलं तर ते काय होईल, ते फिरत राहणार ना रनर. तुम्हाला ऍट एनी कॉस्ट वी हॅव टू रिड्यूस द स्पीड और वी हॅव टू टेक द रेस्टला. जर रेस्टला घ्यायचं असेल तर 100% पाण्याचा फ्लो कंट्रोल केला पाहिजे किंवा त्याला डायव्हर्ट केला पाहिजे. दॅट इज वाय डिफ्लेक्टर इज प्रोव्हाइडेड. हा, second point is braking jet. So this braking jet is provided at the top of the casing. That is a kind of a pipe. ते पण एक प्रकारची पाईप असते, तिथून पाणी आपण हाय स्पीडनं त्या ब्लेड वरती फॉल करत असतो आणि टर्बाइनला रेस्टला आणण्याचा प्रयत्न करत असतो. म्हणजे बेसिक इंटेन्शन टू प्रोव्हाइड द ब्रेकिंग जेट इज टू टेक द टर्बाइन टू द रेस्ट. टर्बाइनला रेस्टला आणण्याचं काम कोणावरती केलं जातं, ब्रेकिंग जेट आणि जो काही स्पियर प्रोव्हाइड केलेला आहे. आणि स्पियर जो दिसतोय तुम्हाला फ्लो ते पूर्णपणे पॅक करतं, म्हणजे पाणी देतं जे फ्लो होते बकेटकडे ते पूर्ण स्टॉप करतं. तर त्यासाठी ही ब्रेकिंग जेटचं पाणी ज्याच्यावर पडलं तर डेफिनेटली त्याचं स्पीड कमी येईल, हळूहळू काय होईल, टर्बाइनला रेस्ट येणार. मग आपण म्हणतो कधी कधी जर आपलं एखादं मशिनरी आयडियली फिरलं तर देर आर चान्सेस ऑफ फेल्युअर ऑफ द बेरिंग्स or something damage, etc. So to avoid such problems of the maintenance, we have to take care. So braking jet must be provided at the top so that we can take the turbine to the rest, or you can reduce the speed of the turbine. Is it clear now? Okay. See, now let us see the working of this Pelton turbine. So this Pelton turbine is also called as an impulse turbine. Why it is called as impulse turbine? Because if you see the inlet of this nozzle, only energy present it is the kinetic energy. Because as we know that in the dam water is stored, dam मध्ये आपण water store केलं असतं, it possesses potential energy. When it flows through the this penstock, when it flows through the penstock, what will happen? It converts potential to kinetic energy. बरोबर. So whatever the water is coming out through this nozzle, it possesses high kinetic energy and pressure energy. Okay, so both energies are available. That is what impulse turbine. Okay, it is giving the impulsing action over these buckets, and this runner get rotates with very high speed. Okay, once it rotates with high speed, that means we achieved the mechanical energy. We achieved here a mechanical energy. ऍक्च्युअली वर्किंग फार सिंपल आहे. जे तुम्हाला व्हिज्युअलाइज होत आहे तेच तुम्ही त्यामध्ये फक्त शब्दामध्ये मांडणी करायची आहे. बघा, our main purpose of this Pelton turbine is to generate the mechanical power, and that mechanical power will be utilized to convert electrical energy by using generator. म्हणजे ह्या टर्बाइनच्या सिरीज मध्ये पुढे जनरेटर फिट केलेला असतो आणि जोगाचा शाफ्ट जो आहे तो कॉमन. So how this Pelton turbine works, that we'll discuss now. When water stored in the dam possesses potential energy, when it flows through the penstock, it converts potential energy to the kinetic energy. When that water moves through this penstock by passing through the nozzle, the pressure and kinetic energy of that water get increases, and that forms one jet of water. So this is a one jet of water. that jet of water strikes to the buckets, and when it strikes to the bucket, the runner will get rotates. Runner will get rotates with a high speed. Okay, so this way we can say that mechanical energy is produced, or the mechanical power is produced, and that mechanical power is utilized for converting the electrical energy by using generator, as the shaft of this turbine and the generator is common. Okay, so this way this Pelton turbine, or you can say impulse turbine, works. Now to take the turbine or to stop the rotation of the turbine, so the process followed is, we are closing this by using spear, we are closing the flow of water toward the turbine side. By using spear, you can just push the spear so that the flow can be controlled. Then at the same time, you can start the passing the water through the braking jet with high speed, so that water falls over the bucket or backside of the bucket, and turbine will come to the rest. Slowly turbine will come to the rest. So this way this Pelton turbine works, and whatever the deflector is provided to deflect the jet of water. If you want to deflect the jet of water, because whenever you want to stop the turbine, फक्त ब्रेकिंग जेट वरनं वॉटर फ्लो करून ते पाणी थांबणार नाही, कारण ते खूप हाय स्पीडने फिरत असते. कारण जेट ऑफ वॉटर म्हणजे यू कॅनॉट इमॅजिन इतक्या हाय स्पीडने त्याच्यावर अटॅक होत असतो, आणि हे टर्बाइन एवढं फास्ट फिरत असतं. नॉर्मली आपण जर एक छोटा घरा एक्सपेरिमेंट केला आणि पाणी आपण फॉल केलं, एखादं हे फिरतं लगेच, तर इथं काय हाय स्पीडने त्याचा अटॅक होणार आहे, स्ट्राईक होणार आहे बकेटवरती पाणी, जेट ऑफ वॉटर. त्यामुळे ते काय होईल, जी काही एनर्जी तयार होईल किंवा जे काही रोटेशन्स असतील ते एकदम हाय रोटेशन्स असणार आहे, आणि we obtain the mechanical energy or mechanical power. Okay, understood? Have you understood? And whatever the spear is operated, it is not operated manually, it is operated automatically as per the loading condition. म्हणजे जे काय तुम्ही लोड कसा असणार आहे त्याच्यावरती ते काय होतं, स्पियर ऑटोमॅटिकली ऑपरेट होत असतो. And the water can be controlled, means what are the flow of water can be controlled, or maybe if you want to increase the speed, so whatever the flow of water will be very high. If you want to decrease the speed, the flow of water can be reduced by using spear. So that operation happening automatically. Are you getting? कळलं का सर्वांना? Hello? Have you understood? No response. समजलं का नक्की?
Yes.
Okay. जर परीक्षेत जर विचारलं बाबा, write a note on or explain the construction and working of a Pelton turbine, can you write the answer of this? लिहिता येईल सर्वांना?
Definitely.
Very good. Okay, so in short, I will give the points related to this Pelton turbine. Please note down. Water is transferred. असं म्हणा पहिल्या सुरुवातीला. Pelton turbine is also known as impulse type of turbine. Pelton turbine is also known as impulse type of turbine. Impulse type of turbine. Pelton turbine is also known as impulse type, IMPULSE, impulse. Impulse type of turbine. Next, water is transferred from the dam. Water is transferred from the dam to the nozzle. Water is transferred from the dam to the nozzle by a penstock.
Repeat sang.
Okay. Water is transferred from the dam. Water is transferred from the dam to the nozzle. The nozzle है ना, छोटी जो है तो nozzle है, लक्षात ठेवा. It is acting like a nozzle because area is very much smaller. हा जेट ऑफ वॉटर करायचं म्हटलं तर त्याला नोझल बसवा लागेल. Water is transferred from the dam to the nozzle by a penstock, by a penstock, by a penstock, comma, through the nozzle water flows out, through the nozzle water flows out, through the nozzle water flows out, through the nozzle water flows out at higher speed of jet of water, at high speed, at high speed jet of water, high speed jet of water, jet of water, full stop. This water jet strikes over the buckets, strikes over the buckets and starts to rotate and starts to rotate and starts to rotate the runner and starts to rotate the runner and starts to rotate the runner. Full stop. Next line. The sphere is operated. The sphere is operated automatically. The sphere is operated automatically to increase or decrease, to increase or decrease, to increase or decrease the amount of water, the amount of water flows, amount of water flows as per the load, as per the load, as per the
Sir,
load.
repeat करा.
Okay. The sphere is operated automatically to increase or decrease the amount of water, to decrease or increase the amount of water flows as per the load, flows as per the load. Full stop. The rotating runner, the rotating runner rotate the generator, the rotating runner rotate the generator, the rotating runner rotate the generator and generate the electricity, generate the electricity, generate the electricity as it is mounted on same shaft, as it is mounted on same shaft of the turbine, as it is mounted on the same shaft of a turbine. Next paragraph. In order to bring the turbine to the rest, in order to bring the turbine to the rest, comma, the nozzle is closed. In order to bring the turbine, in order to bring the turbine to the rest, in order to bring the turbine to the rest, comma, the nozzle is closed, the nozzle is closed, the nozzle is closed by the sphere, by the sphere, and through the braking jet, through the braking jet, through the braking jet, or nozzle, or nozzle, or nozzle, the water falls, the water falls, Falls, the water falls on the back of the buckets, on the back of the buckets, on the back of the buckets. And hence it is acting as a hydraulic brake. And hence it is acting as a hydraulic brake. And hence it is acting as a hydraulic brake. Hydraulic brake. Next paragraph. The deflector is provided. The deflector is provided. The deflector is provided to deflect the jet of water. To deflect the jet of water. To deflect the jet of water away from the striking the buckets, away from striking the buckets, away from striking the buckets, in case load on the turbine.
Repeat kara sir.
Okay. Deflector is provided to deflect. Deflector is provided to deflect jet of water away from striking the buckets, away from striking the buckets, in case load on the turbine, in case load on the turbine suddenly reduced. Suddenly reduced. मग आता हे जे टर्बाइन आहे पेल्टन टर्बाइन हे कुठल्या ह्यासाठी वापरायचं जर we have to go for the high head. Whenever there's a high head we can select this turbine. Whenever there's a high head is there, because in the classification we mentioned the turbine is classified based on the head, high head, medium head and low head. Okay, so it will come under the category of high head. ज्यावेळेस तुम्हाला हाय पॉवर किंवा हाय पॉवर जनरेट करायची असते आणि जी काही हेड असेल ते हेड जर हाय असेल तर वी सिलेक्ट दी पेल्टन टर्बाइन ओनली. Okay, so whatever the quantity of water or whatever it is available in abundant, and at the same time your demand of the generating electricity is more, so preferably everybody go for the Pelton turbine only. Getting? Because it requires more space. If you compare with other types of turbines, it requires more space. Okay, so you can note down, note this turbine is used for high head condition up to 500 meter, up to 500 meter. Okay, so this is the Pelton turbine. In the examination you may find the question, explain the working of a Pelton turbine, explain the working of impulse turbine. At that time you have to draw the diagram, then construction points and working of it. Okay, so if the question will be asked, theoretical question, it may be asked for 5 marks. तर त्यावेळेस तुम्हाला त्याचं डायग्राम काढणं अपेक्षित आहे, त्याच्यानंतर त्याचं कन्स्ट्रक्शनचे पॉइंट्स आणि नंतर लास्टली वर्किंग. दॅट्स ऑल. ठीक आहे. So we'll move to the next type of turbine. Please put the heading Francis turbine. So related video also you can watch on the YouTube. There are a number of videos related to the Pelton turbine you can watch. You can see one video, it is there, or it is animation, not video, it is animation. Getting? So like this, there's a penstock. This is end portion, whatever the end of this pipe, it is very, very smaller. It is a nozzle will be fitted over here, and it produces an one jet of water, and that jet of water will strikes over the buckets, and this turbine runner get rotates. Okay, लक्षात आहे का? Through this animation, can you imagine or can you visualize? लक्षात आलं?
Yes, sir.
Okay, so we'll move next. बघा त्याच्या कन्स्ट्रक्शन मध्ये बकेट्स कशा असतात वगैरे. ठीक आहे. Now next type of turbine, it is a Francis turbine. Please put the heading Francis turbine. Draw this diagram. Please put the heading Francis turbine. Francis turbine. आपण ते पंप काढलेले. Pump is different and turbine is different. पंप मध्ये आपण सक्शन पाईप दाखवली होती, डिलिव्हरी पाईप दाखवली होती. तिथं सक्शन वगैरे प्रकार असतो पंप मध्ये, इथं सक्शन नाही प्रकार. सो ड्रॉ दिस केअरफुली. बघा सुरुवात कशी करतोय मी. सुरुवातीला इनर शाफ्ट दाखवायचं आहे, त्याच्यानंतर हे एक व्हील दाखवा, त्याच्यावरती गाईड व्हेन्स आहेत, सर्क्युलर काढायचे आहेत, आणि ज्या व्हेन्स काढणार आहात इट शुड बी इक्वली स्पेस्ड. दिसतात का हे सगळं व्यवस्थित ड्रॉ करा. त्याच्यानंतर आउटर सर्कल. हा, काय डिफिकल्टी आहे ड्रॉ करताना? काय डिफिकल्टी येत असेल तर विचारा बिनधास्तपणे, पण चुकीचं काय करू नका बघा प्लीज. हे सर्क्युलर आहे लक्षात ठेवा, हे पण सर्क्युलर आहे. दिस इज ऑल्सो सर्क्युलर, but this casing part it is gradually increasing. See, whatever the casing is provided, it is gradually increasing. हे सर्क्युलर काढायचं नाही लक्षात ठेवा, मी दाखवित टिक मार्क करतो. So casing part should not be shown circular, it is gradually increasing. हळूहळू एरिया हा वाढत चाललेला आहे लक्षात ठेवा. And at the bottom there is a draft tube. At the bottom there is a draft tube. Okay, over. Is it over? Over. Okay. Now see this Francis turbine. This turbine is invented by Francis. Okay. So here, this Francis turbine, the construction details. There is one draft tube, tail race, then runner. On the runner, there are vanes. Number of vanes are there, equally spaced. Then there's a guide vanes, guide wheel. Okay. Then there's a casing, and there's a one penstock through which water is flowing. Okay. So what are the casing is there? It is a kind of a spiral casing. It is a spiral casing. The cross-section area get increases from start to end. The cross-section area get increases from start to end. Initially, it is smaller one. It is goes on increasing, and then there's a penstock. Okay, so at the bottom side, the runner is provided. At the bottom side, draft tube is used. Whatever the water gets strikes over this runner, it comes to the tail race through the draft tube. Okay. Now, if you see the construction, this flow passages. So what are the guide vanes are there? It direct the water toward the runner side. So it is acting as a flow passages. म्हणजे त्याला direction देण्याचं काम करते म्हणून त्याला म्हणले की guide vanes. So work of guide vanes is what is the main function or what is the work? To guide the water toward the runner. Okay. So whatever the water comes to the penstock and enters into the casing, then it will come initially at the guide vanes area. Then guide vanes consist of a number of flow passages. So these are the passages 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the passages that guide vanes diverting or guiding the water to move towards the runner side. Runner side ला काय करतात ते push करतं waterला आणि when that water gets strikes over the runner, so and as we know that when it strikes over the runner will get rotates, and that means what we obtain here mechanical energy. Okay, and that mechanical energy is utilized for generating electricity by using generator. Okay, because the shaft of the turbine and the generator is same, right? So when water gets strikes over the runner, so what are the pressure of the water get reduces. Okay, so pressure will become less than that of the atmospheric pressure. So to regain that original pressure and water to make flow out toward the tail race side, the draft tube is fitted over here. So through this draft tube, water is coming to the tail race. Getting water is coming through the tail race. So this way, this Francis turbine works. Basic intention is to generate the electricity. Firstly, we obtain the mechanical energy, that is mechanical power. Then we convert into the electrical energy by using generator. Okay, so very simple working of this Francis turbine. Only this turbine is used when there is a medium head. Okay, Pelton turbine high head साठी वापरतात आणि medium head साठी Francis turbine we can use it. Okay, so firstly I will explain the working once again. बघा याच्यामध्ये काय होतंय, पेनस्टॉक मधून जे पाणी फ्लो होणार आहे विथ हाय स्पीड होणार आहे. ज्यावेळेस ते पाणी इकडं ह्याच्यामधील गाईडव्हेनच्या इथं, त्यावेळेस गाईडव्हेन म्हणजे काय, इट इज ऍक्टिंग ऍज अ फ्लो पॅसेजेस, आणि ते काय करणार, ते वॉटरला गाईड करणार टुवर्ड द रनर साइड रेडियली इनवर्ड्स. रनर वरती अटॅक होणार ते फ्लो ऑफ वॉटर, आणि अटॅक झाल्यानंतर काय होईल, प्रेशर त्याचं जे काही एनर्जी असणार आहे energy will be reduced, but this runner will rotate with high speed. ह्याच्यामध्ये जे काही एनर्जी कमी झाल्यामुळे प्रेशर इज गेट डिक्रीजेस. आणि इथं इम्पॅक्ट झाला ना, कारण इम्पॅक्ट झाला की काय होणार आहे, जे वॉटरचं प्रेशर असणार ते कमी होणार आहे. अँड टू रिगेन दॅट प्रेशर and water to flow out to the tail race, so draft tube is provided at the bottom side of the Francis turbine. Okay, and through this draft tube water is taken to the tail race. Again it is recirculated through the penstock. Recycling is possible. Whatever the water is used, okay, it will not get wasted. तुम्ही परत ते पाणी परत रिसर्क्युलेट करून हे रनर तुम्ही रोटेट करू शकता आणि you can obtain the mechanical energy or mechanical power. अंडरस्टूड? एकदम सोपं आहे, लक्षात ठेवा. हाय स्पीड पाणी आलं की ते पहिला इकडे ते पूर्ण केसिंग भरणार, तिथून ते इथे येईल ब्लॉकेज मध्ये, काय म्हणतात आपण फ्लो पॅसेजेस मध्ये, त्याला गाईडवेन म्हणतो आपण. गाईडवेन काय करणार, परत ते पाण्याला आतमध्ये पुढे पुश करणार. ओके, आणि ते एकदा रनर वेन वरती पडलं की ते परत हा काय होणार, रनर फिरणार. ज्यावेळेस ते पडल इम्पॅक्ट होईल पाण्याचा, त्यावेळेस त्याची प्रेशर एनर्जी वगैरे कमी होत जाणार. आणि त्याच्यामुळे काय होईल, when pressure decreases, so pressure becomes lesser than that of atmospheric pressure. आणि त्याच्यामुळे to regain that original pressure, so we are making the water to flow out through the this draft tube. Okay, to regain the original pressure, we are flowing the water to the tail race through the draft tube. So this way this Francis turbine works. Clear? So in the notes I have given in very simplified manner, so you can refer it. Okay, maybe in the next lecture I will dictate the working of this Francis turbine, and the last point will be covered in the next lecture. Okay, so tomorrow my lecture is not there, but still I will request your class coordinator to give me one lecture, and once I get tomorrow I will finish this chapter and we can start the new topic from next onwards. Okay.
You can take my lecture, sir, tomorrow.
Okay, tomorrow I will take your lecture, sir. Power sir have given permission to take his lecture, so tomorrow I will take. Thank you very much. Do the attendance. Roll number 1,
Present, sir.
2,
Present, sir.
3. Roll number 3, 4,
Present, sir.
5,
Present, sir.
6, 7,
Present, sir.
8,
Present,
9,
Present, sir.
10, 11. Roll number 11, 12,
Present, sir.
13. Roll number 13,
Present, sir.
14,
Present, sir.
15.
13 present, sir.
Noted. 15. Roll number 15, 16,
Present, sir.
17, 18. Roll number 18,
Present, sir. 18.
19,
Present, sir.
20, 21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31, 32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37, 38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 54,
Present, sir.
55,
Present.
56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59.
Present, sir.
Okay. 59, I asked you to make call, but you are not calling me. मला आज कॉल कसा नाही 4 वाजता. Okay. 59, can you hear me? Hello. Roll number 59, please call me today at 4:30. I want to discuss some important points with you. Okay, I will repeat the absent numbers. Roll number 3, 6, 10.
Roll number 3 present.
Okay, 6, 10, 11, 15, 20, 31. These are absent. Okay, thank you very much. So you, sir, is in front of me. I will end the meeting now. So please join immediately.